Hello David, and welcome to WPP number 4 on Unity Concept 3. And this problem is titled Farmer John. Why John? That's probably the name of a farmer. Okay. The problem is a farmer has 100 feet of barbed wire to enclose a rectangular pen in which his fence is one side of a rectangle. Okay, so what we do first. First, we draw out what we think it will look like. And it's gonna look like this. Barbed wire all on one side. And this side is gonna have nothing, because it's only one side of a rectangle, not the other side. So from there, we have to set our variables for our width and our length, and we'll just use x for length or base, whatever you want to call it. And for our height or width, again, whatever you want to call it, that is our y. Okay, now I have to set up two equations, one for area and one for perimeter. Area, very simple. Base times height, length times width. So it's just going to be xy. Perimeter, just adding up all sides together. And that's going to be, let's see, we have two x's, 2x plus y. That was our equations. We have that set up. That's great. Okay. So from there, now you have to solve for y. Solve for y. And which equation is going to be the best to use? That's right, perimeter. So in order to solve for y using perimeter, we take the 100 feet of barbed wire, and that's what we're going to set this equation equal to. So we're going to set this equal. Oh my god, it's going to be like this. Oh, covering everything up. Equals 100. It's so white. I'm just gonna put it back. Equals 100. Okay. So what do we do? Right there. We're gonna subtract 2x on both sides. So y can be by itself. So y. So this equation is not gonna be y equals negative 2x plus 100. Okay, so now we have to use the area equation. And how are we gonna put together this and this? Very simple. This is gonna get input into here. Just like that. Okay, so then now we have to set it up. So A equals x parentheses minus 2x plus 100. Remember, we simply just move this into this because it's a y and it was xy. So we were able to plug this into this. And what do we do when we see parentheses and an x or anything outside of the parentheses? We have to distribute. So then we get negative 2x squared plus 100x. And then from there we have to use the equation negative b over 2a. So our b is 100. So again, we have to use negative b over 2a. And it's going to be negative 100 over 2 negative 2. This is our a. This was our b. Okay, so then we just do the math. Move this up. And it's going to be negative 100 over negative 4. Negatives cancel out. And this can simplify into 25. So our x 25. So x equals 25. So now we find the x, we have to find, that's right, the y. So we go back to our perimeter equation, and we put 25 back to this. So we're gonna get 2, can you see that? Yes you can. 2 over 25, 2 times 25 plus y equals 100. So you're gonna get out of this 50 plus y equals 100 minus 50 minus 50, y equals 50. That's great. So now we have found our dimensions. Am I correct? Yes, we have found our dimensions. So 25 and y are our dimensions. So our dimension, let me try to find space. Dimension. Whoops. So I'll forget about that. So dimension is going to be 25 feet times 50 feet. Box. Okay, so we found our dimensions by using the perimeter equation. Now we have to find our maximum, which is basically the total maximum area. So how much we can use is 100 feet of barbed wire. So you go back to our area equation and we plug in, and move this over here. So A equals, hope you're following me, A equals 25 times 50. Okay, because we plugged in this x, where's the y? This y equation to get this. Be very clear. And that is going to equal 1,250 feet squared. So that is our total maximum area. And that got to solve this problem. Hope you enjoyed, hope you learned, and thank you for watching.